Yeah.
So we'll try this again. Where you're going to tell me where this equation here came from.
It's 20 calculators plus 10 measuring tapes equals $495.
So it's coming from that first part there. What do C and M here represent?
C equals calculators and M equals measuring tapes.
Which is what everyone always wants to say, right? Remember, your variables represent a number we don't know.
The amount. No. How many, or how much they cost.
There you go.
Yeah.
We know how many they're buying, so you would multiply how many they're buying by the cost. So we could say C is the cost of
Calculators.
Yep, the cost of a calculator. And then M would be,
Cost of measuring
there you go,
tapes.
the cost of a measuring tape. Ooh. Okay, so that question said, what do the solutions for each equation represent? You told me where this equation comes from. For it to be a solution for this equation, just the first equation, what does that mean?
It would be how much it would cost to buy 20 calculators plus how much it would cost to buy 10 measuring tapes. Or well, it would give you the price for buying that many.
It would give you, but are we already given the price of buying that many?
No. So you're also finding the price for one of each.
We're finding the price of one of each, but the price, the total price of 20 calculators and 10 measuring tapes, the total cost is, you already told me earlier, is the $495. So for it to be a solution just for this equation, it's giving us the possible price of each of these so that the total price comes out to be $495.
Yeah.
How many possible solutions are there for this one equation here?
One.
For that?
Well, I guess there's infinitely many.
So you switched from one to infinitely many. Tell me why.
Well, no, there's not, because you can, if you're buying specifically 20 calculators and specifically 10 measuring tapes, and it specifically equals $495, then the price for each of them has to be a specific number.
The price of them, each of them has to be a specific number. So you think there's only one possibility of numbers we can put in here to get $495?
Yes.
So I'm going to challenge you this. You come up with a possibility. I've got a possibility in my head. And if there's only one, it means we should be thinking of the same thing, right?
Yeah.
But
Well,
you didn't sound
okay.
confident.
No, because I think I am right. Am I? I don't. Because if you're specifically buying 20 calculators plus specifically 10 measuring tapes, and when you buy that many, it equals specifically $495. But I guess, like how I said before, no.
It makes you think, right?
Because I guess no matter how big of a number it would cost for 20 calculators, you could still get that number down to $495 with the 10M. So it could be infinitely many.
I like how you reason that. No matter what number we put here, you could find a second number so that it equals $495. So you're thinking there's a lot of different options for the cost of calculators, but no matter what number you put there, there's another number you can put here to get $495. So I heard you get there eventually. I think the easiest way to see that there's multiple options is, let's pretend in this like lovely teaching world, those calculators are free. Maybe the cost of each calculator was $0, and then there's a way for me to figure out what cost this would need to be to give you $495. Or maybe those measuring tapes were free, and this was the $0. there's still a way for me to figure out a cost here to give you $4.95. Maybe the calculators were $1. This is more into like what you were thinking. The calculators could be $1. There's a way for me to figure out how much those measuring tapes cost. I think the part you were getting hung up on a little bit is we know that there's going to be a single cost for each of them. We know there's only going to be one right answer. But if you're only looking at one equation, there's lots of different possibilities. If I had more students in this room, I would have asked that same question, like, will you try coming up with a solution? Someone else is probably not going to come up with the same one as you because there's lots of different combinations to give you that total price. Similarly for the second equation, if I just give you that,
Infinitely many.
same idea. This one I think is easier too because there's no number you're multiplying here. If we said that one measuring tape cost $100, you could solve for the other one. I think it's harder to see when you're talking about stuff like cost of things, but the same idea is true from before. If you're looking at an individual equation, there are infinitely many possibilities. If I give you this set of information, how many possible solutions are there?
One.
Yes. So the part B says find the solution to the system. This is where we're going to get into the solving and finding that one possible solution. Here's our system. What do you want to do to solve it?
I guess you could do anything.
Yeah, you're quite right. You can do anything.
I guess it would be easiest maybe to substitute.
Sure. Tell me what you're thinking we're going to substitute.
Probably the bottom equation.
Uh-huh. What is being substituted?
You have to get m equals.
Uh-huh. So if I want m equal, what does m equal?
Well, m plus 8c equals 178.
Mm-hmm. But I heard you say you want to get m equal to something. So what are we going to have to do to make that happen?
Get m by itself, so you'd have to get rid of 8c.
Mm-hmm.
So you could subtract 8c.
Yeah. I like how you're mixing up our methods to solve. That first one we used elimination, let's practice some substitution. So minus our 8c. Okay, so I've solved for m. What do you want to do with that now?
Then you would plug it into the top equation.
Yep, when we substitute into that top equation, what's it going to look like? I think I'm going to put it up here.
20c plus.
Nope, I've been wanting to find this dead black marker. I knew it was somewhere. Okay, we'll try again. 20c
Plus 10, and then parentheses is the multiplication. 178.50 minus 8c
8c. Oh,
equals 495.
okay. From there?
You would carry the 10.
Mm-hmm. So it'll stay 20c plus 10 times $178.50. Do you know the trick when you're multiplying numbers that end with 0? If you're multiplying this by 10, it's just moving that decimal point over one place. So like think about like 8 times 10 gives you 80. It's moving that decimal point over one. Same idea.
So it's 1,785
Mm-hmm.
equals 495.
We're missing something.
And then 10 times 8, negative 8c
Mhm.
would be negative 80c.
Yep. From there?
From there, could you combine
Mhm.
these?
Yep, they're on the same side of the equation, so we can combine.
It would be negative 60c
Yep.
plus, plus 1,785
Equals.
495.
Yep.
And then subtract 1,785 from both sides.
Fun. That should be a 1.
Um,
Negative 60c equals It can help if you're doing this by hand, if you put the larger number on top for that subtraction.
The 1,210.
You're saying what?
1,210.
1,210. I do not agree.
No.
So I agree with the 0. 8 minus 9 we can't do, so we're going to have to come in here and borrow.
That would be
6 and 18.
Oh, so it'd be 90, 1210.
1290?
Yeah.
Okay. So we've got...
1290,
and then we've got our negative. I didn't want to... Where did it go? I didn't do it earlier, but I did want to give you a calculator for this lesson just so we could focus on the word problems and not on the fun math. But you've been doing so good so far. Feel free to continue if you want. What's our last step?
Divide negative 60 on both sides. Make
Yeah.
negative 1,290
Divided by 60.
divided by 60.
Another fun trick you can do is when they end in zeros, the zeros cancel each other out. So we really just have to do the 129 divided by 6, which gives us
Be like 21 point something, wouldn't it?
it would be 21 point something. What's the point something? You can I didn't give it to you just to taunt you. You can do it.
0.5?
Mhm. Yep. So in this situation, what is C?
C is the cost of the calculator.
Mhm. So we've got the cost of the calculator is
21.5.
Or if we're talking about cost, we would say
$21.50.
yeah. So that's part of our solution. The other part,
The cost of measuring tape.
yep. Which equation do you want to use?
The bottom one.
I agree.
So it'd be 8 times 21.50 plus n equals 178.50.
Mhm.
And then 8 times 21.50 would be so it's 43 for two 21.50s, and then 43
Oh.
plus 43 is 86, so that's 4, and then 86 plus 86 is 172.
Love that mental math. I don't know if that picked up on the video, but I'm just going to repeat it. So he said, well, 2 times 2150, he got the 43. So that's 2 calculators, 4 calculators, and then that got us to our 8 calculators. Nice. I love that. So we got 172 plus our measuring tape gives us the 178.50. Can you do, if you can do all of that in your head, I know you can do this math in your head. What's the cost of the measuring tape?
178.50 minus 172 would be 6.50.
Yeah. Woo! Isn't that some fun math? I don't think there's any more decimal ones, but I did do this just because it came up in that last problem, and I meant for it to come up in this lesson. But systems can have quite large numbers in them. They can have decimals in them. It doesn't mean we're doing anything wrong, right? It just means the cost had some sense in it. And you did a great job with that. There is... All right. The second part to this, I'm trying to decide how much I want to erase. I'm going to leave calculator and then the 650 for the measuring tape. Okay, I'm going to erase the rest of this. As I'm erasing, the second part of this question says, to be reimbursed for the cost of the supplies, the teacher recorded items purchased, 28 calculators and 11 measuring tapes, amount $673.50. The first part asks, write an equation to represent that one sentence there. What equation could we write?
28C plus 11M equals 673 plus 50.
Yep, you got it. The second part says, how is this equation related to the first two equations we wrote?
Because with the first two equations, or with the system, it was,
I can't
the
remember.
whole reason there was a system at all is because the word problem was she made one order which was 20C plus 10M, and then she made the second order which was 8C plus M. So 28C plus 11M is just both of the orders combined.
Yeah. I can't remember from memory what the costs were, but you said it. You said the reason we had a system, we had those two equations, is because there was two separate orders with two separate totals. And I heard you say this one here is just the total of these two. We could say the total or the sum or what you get when you add those two equations together. So then for this one, kind of like what I had asked you last time, how many solutions are there to this single equation?
Not infinitely many.
Yeah, so we go back to that infinitely many option. There's tons of combinations where you could find the cost for each of these that would give you this total cost. So why having that system helps is because it gives us more information. It gives us two equations. When it comes to solving equations, if you have two variables, you're going to need at least two equations to solve it. If you've got two variables but one single equation, you're never going to be able to solve. I mean, you can move stuff around and rearrange it. We could come up with like C equals 673.50 minus 11M divided by, like, we can solve it as a literal equation. But the only way we're going to get this is if we've got two equations. I'm a bit out of breath. You're doing great. How do you feel?
Oh, pretty good.
Like I said, I really like this lesson. It's putting a bunch of stuff we've talked about all together, which I think is fun. Hopefully you at home think it's fun. The last part to that one is I've just got it graphed again. So I graphed those two equations. This time everything's labeled correctly. But we could see again, like you had said before, there's a ton of different combinations that would give us that possible total. But there's only one combination of prices that would give us both of these things. The last of these are just focusing on writing the system, so we don't have to worry about solving things anymore. Students can struggle sometimes when the information isn't given in like a very clear way, and to make that make more sense. For each of these, the equation was written out all together in a single sentence. So here we've got the 20 calculators, 10 measuring tapes, total cost. I can see that sentence right here. There are times where the information isn't given in such like a clear fashion. So I want to focus on how we can get systems from those. So for example, for what I'm talking about, we've got a total of 20 children and adults go to the zoo. Adults cost $10 and children cost $5 at the zoo. They spend a total of $125. Write a system of equations to find how many adults and students went. So this is an example of where there's like a little bit of information all over the place. It's not like the two sentences match up to two equations. For a problem like this, where you're looking at it and you're like, I'm not quite sure what those two equations are going to be, I think a good place to start are, what are our variables going to be? What are those two unknowns?
The amount of children and adults.
The amount
that
of...
have gone.
Okay, so give me two letters.
A and C.
So A is going to be...
Adults.
Yep. and you use the word amount, which I love, the amount of adults who go. And then C is going to be
the amount of children.
Yep. Do you know the reason I love that you said amount and not just adults and children?
Because if I just said adults and children, it doesn't mean the same thing as the amount of.
I could have changed this just a little bit, where instead of finding the amount of adults and children who went, we could be trying to figure out the cost of adults and children. So when it comes back to defining your variables, that's why we push you to be specific, because it could be the amount of adults, it could be the cost of adults, it could be, I don't know, the age of adults. It could be a lot of different numbers. So you've got our two variables. Once we've got this is going to help guide us when we go to write our equations. So the first sentence tells us a total of 20 children and adults go to the zoo. How can we use that information?
Well, you have to have two equations. One of the equations could be A10 plus,
No?
10A
Okay.
plus 5C equals 125.
Equals. Okay. So I'm going to pause there. Tell me what this equation here is saying.
It'd be $10 per adult plus $5 per child equals $125.
Nice. So what this equation here is describing is really the cost. You're saying it's the cost of adults plus the cost of children, give you that total cost. And you're right, that's one equation. Second equation?
Can it just be A plus C equals 20?
What's that equation telling us?
The amount of adults plus the amount of children equals 20 total people.
Yeah, and I like how you went back to what you had said for those variables. You said the amount of adults plus the amount of children is 20 total children. You did really well with this. This one here then is describing, instead of cost, this one's describing
the amount of people.
Yeah, amount of people. What I'm doing over here is another piece of advice if you're struggling, is look at this information. Everything they're telling us falls in one of these two categories. It's either describing the cost of something or how many people are going. Nice. There's only one last one for us to look at. We'll see how well you do with this one. This one is saying, okay, we've got the total number of M&Ms that Iris and Maria have is 100. If Iris has 8 more M&Ms than Maria, how many does each have? Write a system of equations that could be used to solve this problem. Tell me what you're thinking we want to do first.
Label the, I don't know the word, variables?
Yeah. Sure. Which variables do you want to use?
I guess they would be Iris and Maria.
So we should do
I and M.
I and M. I heard you say Iris and Maria, so I is...
So it would be the amount of M&Ms that Iris has and the amount of M&Ms that Mariah has.
Iris has number of... Can anyone actually do this symbol with their hand? I don't...
It's kind of weird to draw.
That's not right. I'm going to go back to that. M&Ms that Maria has. Nice. My handwriting has gotten worse and worse as this lesson goes on. So then our system, you've got your two variables.
So one of the equations you could do could be 8i plus m equals 100.
What's this equation here saying?
Well, no. Because
I heard you change your mind, but let's still talk through what this equation here is saying. What does this say?
that says that she has 8 of, or well, something to do with 8.
Yes.
But
What does it mean when you put them next to each other like that?
It means you would have to multiply by whatever I is.
Yeah, so this is 8 times the number of M&Ms Iris has, plus the number of M&Ms Maria has equals 100. Let's go back to that 100 there. What are they saying equals 100?
The total number of M&Ms that they both have.
Okay. So I like how you worded it there. It's the total number of M&Ms they both have. We're not multiplying anything by 8. If I want to show it's the total number of M&Ms they have,
so it would be
if we said you've got some M&Ms, I've got some M&Ms, I want to find the total, what would you have to do?
You'd have to add them.
You would have to add what?
The amount of M&Ms of each person.
Okay, so put what you're saying, put it together in an equation. I want to show.
It would be I plus M plus 8, maybe? No.
Equals 100?
Yes.
So let's talk through that. This is saying
the number of M&Ms that Iris has plus the number of M&Ms that Maria has plus 8. So it would be 8 plus I plus M. Because Iris definitely has 8 more M&Ms, but no, so that wouldn't be that.
Focus in on what we've got right here. You told me 100 represents what again?
The total number of both of their M&M amounts.
And you told me to find that total number. What do we have to do?
You could divide. No, not late.
You said it earlier. Define if you've got, forget Maria and Iris, if you've got some M&Ms, I've got some M&Ms, we want to know how many total M&Ms we have.
We have to add up both amounts.
Add up both amounts. Are we adding anything else in?
No.
No, we're just adding your M&Ms, my M&Ms. That gives us the total. Not adding anything, not dividing, not multiplying, just adding yours and mine equals the total.
Okay. So
I heard the...
just I plus M equals
There you go.
100.
Yep.
But
If I put words back to that, I see where you want to go. If I put words back to that, that's just saying the number Iris has plus the number Maria has equals 100.
Yeah.
What you've been trying to do is jumpstart that second equation. The other information they tell us is if Iris has 8 more M&Ms than Maria. That's separate information we can use to write a separate equation. What are you thinking for that one?
So Iris has 8 more M&Ms than Maria, but we don't know how many either of them have to begin with.
Mm-hmm.
So if you wanted to, I don't really know.
Is that sentence describing how many Iris has or how many Maria has?
How many Iris has?
So that means our equation could start, if it's just telling you how many Iris has, my equation can start with I. If it's telling you how many Iris has, we could say I.
Oh, I equals.
This sentence here is telling you, it's about to tell you how many Iris has, so we're going to say Iris has this many.
M plus 8. Oh.
Another way of thinking of it, that word has there, I could reword the sentence. It would sound a little weird, but I could instead say, if the number of M&Ms Iris has equals 8 more than Maria, I can reword it to use that word equal in that sentence. I think these sentences where they say like more, like 8 more or 8 less can get really confusing, and it's really easy to have these numbers. I said numbers. These variables in the opposite order. Sometimes students might accidentally say m equals I plus 8. I think for ones like this, an easy way you can check is make up a pair of numbers and see if it works in this equation. might not necessarily be the final answer, but for example, if I told you Iris has 10, using this sentence, how many would Maria have then?
2.
Nice. If Iris has 10 and Iris has 8 more than Maria has 2, see if these numbers work in that equation you just wrote.
They do not.
Tell me why.
Because 10 plus 2 does not equal 100.
I
But
is,
even with
oh, I see what you're saying. I'm talking about just this one right here.
Yeah, but even with that, it would be. Well, in that case, it would be correct.
Because 10 equals 2 plus 8.
Mm.
That kind of you can always do something like that, make up numbers to go with that information to help check to make sure your equation is good. I see what you're saying though. It's not a total of 100. Another way you can think of that line right there, so this is one way. Some people think of it as if Iris has 8 more M&Ms than Maria, it means the difference between the two amounts is 8. I've changed it to use the word difference. Difference means subtraction. If Iris has 8 more than Maria, it means if you took Iris's, subtracted Maria's, you're left with 8. So another way you could write this is with subtraction. You could say, well, if Iris has more, she's going to start. If you subtract Iris and Maria, it equals 8. Are these equations different?
Yes.
Tell me why.
I guess they equal the same thing,
They definitely look different. I'm not trying to trick you into a question. They look different. I've written different things. Are they saying the same thing though?
Yes.
How do you know?
Because I equals m plus 8.
Can I change this one to look like this one?
Yes. But yeah.
How?
If you subtract 8 from both sides.
If I subtract 8 from both sides, that would give me I minus 8 equals m. Not quite. But if you were to subtract
M. Oh.
There's the sound I love. That would give us the same equation. So you don't need to have all 3 of these written down. Depending on the student, though some people think of it this way, this seems like the way you were more inclined to come up with it. Other people read that sentence and they say like, oh, okay, so there's just a difference of 8 M&Ms. You could also get this equation. It doesn't matter which one you write because at the end of the day, they say the same thing. They're just rearranged differently. I'll leave that one there since that's the one you came up with. This was the last example. How are you feeling?
Better now.
Really?
Yeah.
Okay. There are 2, I think there's one at the bottom of that page and then one on the back maybe for you to try. Or maybe they're both at the bottom. Yeah, those 2. Those are for you to try now. Okay. And the focus is just writing on the system, so you don't need to worry about solving these. People at home, this is one of them. And this is the other one. All right, goodbye.